Hello everybody and welcome back. We're on question number 19 of the 2002 Grade 10 Cayley competition. So question 19, very simple one-liner. It says, the sum of the digits of the integer equal to, let's see here, thousands, millions, billions, trillions, 777 trillion, 777 billion, 777 million, 777,777 squared minus 222 trillion, 222 billion, 222 million, 222,223 squared is... Alright. So it's quite clear that these numbers are way too big to use our calculator. Now, we're allowed calculators on the competition, but let's see, we might even have that number added in. It will, but it's not happy about it. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's a very, very big number that I really don't want to deal with right now. But when we do a question like this, we realize, well, there's no way we could do this on our calculator, and there's certainly no way we can do this out by hand. We have to start thinking and being a little clever about it. Now, I notice two ways to do this right off the bat. The first way, which I would recommend to everyone just because it develops a nice technique, is try smaller cases. I notice I've got a lot of 7s, then a lot of 2s followed by a 3. So I might take a look at just 777 squared minus 223 squared and see if I can work out what that number is. And then try and add another 7 and another 2. So 7,777 squared minus 2,223 squared. And work out what the answer to that smaller problem is. And maybe, just maybe, I'll notice a pattern with the numbers that they're getting. And I can generalize that pattern to 15 7s and 14 2s followed by a 3. Okay. The other way we can do it, and I think I'll do both actually, is a difference of squares. I'm noticing that I got a number squared minus another number squared. That's known as difference of squares. So, I don't know which to do first here. Let's do the difference of squares one. So, if I have two numbers and it's written like this, something squared minus another something squared, I can factor that as x minus y, x plus y. So that's something that immediately catches my eye. And with these numbers, I'm noticing that I'm on the right track because with all these 7s here, I need a better way to write this. I don't think I'm going to think of a better way to write this. 3, 1, 2, 3. Squared minus 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and then an actual 3. When I do this, I get the difference in these numbers clean that up just a little bit. The difference of these numbers and then the sum of these numbers. And this sum catches my eye because if I perform this sum, I think it turns out to be a power of 10. So 7 plus 3, that's a 0, and then we carry the 1. Oh, look at that, that's 10. Oh, look at that. It's just going to keep going. And we're going to get a 1 with 15 zeros after it. So that's 10 to the 5. Or sorry, 10 to the 15. So whatever this number is, it's going to end in 15 zeros. And none of those zeros are going to add anything to the sum of the digits. So we've now changed the problem into, instead of summing these, figuring out the sum of the digits in the difference of these two numbers. So let's work out the difference here. Now, if I hadn't gotten something really nice like 10 to the 15 like I did, I might suspect that there's something else at work and that I've taken the wrong path with my difference of squares. Let's see. So I've got a 4 here, and then I'm just going to get a bunch of 5s. So that's actually a pretty, I mean, it's very long to write out, but it's pretty easy subtraction here. And we have 14 5s and 1 4. So 14 5s plus 1 4, well, 14 times 5 is 70 plus 4. The answer should be 74. And 74 is one of the answers. It's C. So we get C right there. Now, that was if we did it with difference of squares. But as I said, another way of doing it, especially with questions where they have big numbers or very lengthy computations, is to do a couple smaller, simpler ones that retain the essence of the pattern here. And the pattern's pretty obvious. And then generalize and see if we can come up with a better answer. So the pattern here is we're doing a bunch of 7s minus a bunch of 2s followed by a 3, the difference of those squares. So let's take smaller examples, okay, and see what we can come up with. Because the big ones can't really be done by every calculator, but the smaller ones. So this is way number 2. Let's try smaller cases. So how about if we just have 2 7s squared minus a 2 and a 3 squared? What does that number actually come out to be? Well, we can work it out with our calculator. 77 squared minus 23 squared. That's 5400. That's easy to add up. 9. How about if we added another one? 777 squared. 223 squared. Well, that's another one that's simple enough that any calculator can do it and display the correct answer. That's 554000. How about 4 7s squared minus 3 2s and then a 3 squared? Well, it's another one where my calculator is giving me the answer here. And I don't know if my calculator will do the next one, but I'll find out. But already you can definitely see a pattern happening. Yes, this will be the last one my calculator will properly display. Five, 5, 5, 4, and then 5 zeros. Okay, so I'm noticing a pattern. So if I have n 7s, and then I'll have n minus 1 2s followed by a 3, then that works out to be a certain number of 5s followed by a 4 and then a certain number of zeros. So if I had 2 7s, I worked out to 2 zeros. If I had 3 7s, I worked out to 3 zeros. So it'll be n many zeros. And this tracks with what we already learned with our first technique. We had 10 to the 15, so it ended in 15 zeros. How many 7s did we start with? 15 7s. Okay, so we've worked out the actual pattern. We can do this not just for the one that they gave us in the question, but for anything fitting this pattern. Okay? So how many 5s do I get? Well, when I had 2 7s, I had 1 5. When I had 3 7s, I had 2 5s. When I had 4 7s, I had 3 5s. So I'm going to have n minus 1 5s. So the sum of the digits, well, the zeros don't do anything. N minus 1 times 5 plus 4. So we count up, we have 15 sevens. So the sum is 15 minus 1 times 5 plus 4. Well, that's 14 times 5 plus 4. And once again, we get our answer here, 70 plus 4. 74. So either way, we got C. Okay. So that was a nice little question. It probably looked a little scary, but we had two approaches we could have applied to it. And I like that. I like when there's two different ways we can do the question. Okay. So that wraps up question 19. We're on to question number 20. And hopefully you guys will join me for question number 20 in the next video, and I'll see you there.